Have you ever imagined how they get the mass or the weight of this object, or even the speed of this car, or the length of this table? Now, in physics, we measure the things around us using physical quantities, and to avoid chaos, such as different countries or different scientists having different value for the mass, the speed of the car, or even the length of the table, we have devised a means to ensure consistency. We've organized these quantities into two categories. First is the fundamental quantity, and second is the derived quantity. What is the fundamental quantity? Fundamental quantities are a set of independent physical quantities that are chosen by convention to form a basis for a system of measurement. When we say chosen by convention, it simply means that we all, as scientists, actually adopt it, or majority actually agree to use it. How do we agree that 1000 meter make 1 kilometer, or even the value of pi is actually 3.142? These are chosen by convention or by agreement. This fundamental quantity have fundamental unit. What do you understand by fundamental units? These are actually the basic unit of measurement of the physical quantity that are defined independently and cannot be broken down into simpler units. In summary, each fundamental quantity have a unit. For example, we have length as fundamental quantity, and what is the unit? Meter. Take a look at this table. You notice that you can measure the length, for example, and you can say, okay, this table is 5 meter or maybe 1 meter long. Now, one is actually the quantity, while meter is the unit. Note that the key characteristics or features of fundamental quantity is independence. They are completely independent of other quantities, arbitrary choice. They are chosen by conventional agreement by scientists. Underivable, they cannot be derived from other quantities, and they are actually the basis for measurements. That means they are actually the foundation for measurement. The seven fundamental quantities are mass in kilogram. Kilogram is the unit, length, meter is the unit, time, seconds is the SI unit. We have current, which is in ampere, we have temperature in Kelvin, amount of substance in mole, and the last is luminous intensity. The unit is candela. Note that all the units being mentioned above is the SI unit, which is the International System of Units. This system is the modern form of the metric system and is the world most accepted method of measurement or system of measurement. Now let's talk about derived quantity and unit. Let's assume the fundamental unit is actually the block which you can use to build your house. You can use this block to build various structure. The derived unit can be considered anything like a one bedroom flat, which the blocks can build, two-bedroom flats, a duplex, and all that. So derived unit is actually gotten from the combination of two or more fundamental units. Sorry, I'm always using the word unit for quantities. We have derived unit and we have derived quantity. Now, derived units are actually formed by the combination of fundamental units. You combine fundamental units, you also get derived unit. Just the way you combine fundamental quantities and you get derived quantity. Let's talk about the characteristics of derived quantity. Now, they depend on fundamental quantities. How do they depend on fundamental quantities? They are actually formed by combining fundamental quantities. They can be calculated, not measured. For example, volume. How did you get volume? Volume is a derived quantity. You calculate it from various lengths. How do you get acceleration or force? You calculate it from various parameters. So these are derived quantities. Even their units, derived unit is actually formed from fundamental units. Let's take a look at some examples of derived quantity and their unit. Take a look at the table. The first one there is area. Now, if you notice, area is derived from two lengths, the length and the breadth. Now, take a look at the rectangle. You can see that we have the length and the width or the breadth. Now, the width or the breadth is actually also length. You can see that that is 4 kilometers, while another is the length is actually 7 kilometers. So this derived quantity area is gotten from the combination of fundamental quantity. The next is volume. It's also gotten from combination of fundamental quantity. We have the height, which is length. We have the area, which is also two lengths. Now, take note of their unit. The unit of area is meter square, which is, remember, meter is actually a fundamental unit. But when you square it, meter times meter is now a derived unit, showing that this unit is gotten from the combination of fundamental quantity. So derived unit again is gotten from the combination of fundamental unit. All right. Take note of velocity, which is displacement. Displacement is distance. All right. All over what? Time. Two fundamental quantity. Acceleration again. Velocity all over time. So we realize that we have various derived quantities being highlighted on the board, and they are gotten from combination of two or more fundamental quantities. Their unit is actually highlighted on the screen. Other derived quantity include force. You can see the combination there, and you can see the unit, pressure, energy, and others. They are numerous. Now, it should be noted that since derived quantity is formed from a combination of two or more fundamental quantities, we have so many numbers of derived quantities. In fact, this system of fundamental and derived quantity is the very base upon which the modern physics and engineering is built. This is just a simple lecture on fundamental and derived quantity. Thank you for watching.